So now I'm going to solve some question answer from shear modulus, and here is the first question. A metallic cube whose each side is 10 cm is subjected to a shearing force of 100 kgf. The top face is displaced through 0.25 cm with respect to the bottom. Calculate the shearing stress, strain and shear modulus. So first, the given data are the length of the side is given, so 10 cm. Then shearing force F is equal to 100 kgf. Then the top face is displaced through 0.25 centimeter. That means delta L is given, which is 0.25 centimeter with respect to the bottom. Now we have to calculate the shearing stress, strain and shear modulus. So first we are going to convert this all of the data in a SI unit. So first 10 divided by 100 meter, which is 0.1 meters. Then kgf to Newton. So 100 into 9.8 Newton. Then here also 0.25 divided by 100 meter. So 0.25 into 10 to the power minus 2 meters. So first, shearing stress, which is equal to force upon area, and here the area is L square. So force is 100 into 9.8 Newton divided by L square is 0.1 square, which is equal to 9.8 into 10 to the power 4 Newton per meter square. Then shearing strain. So strain is equal to theta, which is equal to delta L upon L. So delta L is 0.25 into 10 to the power minus 2 divided by L is 0.1. So this is equal to 0.025 radian. Okay. Then lastly we have to calculate the shear modulus or modulus of rigidity. So eta is equal to shearing stress divided by shearing strain. So shearing stress is 9.8 into 10 to the power 4 Newton per meter square and strain is 0.025. So after calculating this, we'll be getting 3.92 into 10 to the power 6 Newton per meter square. Okay, so these are our answer. First, the shearing stress is 9.8 into 10 to the power 4 Newton per meter square. Then strain is 0.025 radian. And then the shear modulus is 3.92 into 10 to the power 6 Newton per meter square. Question number 2. An Indian rubber cube of side 7 cm has one size fixed while a tangential force equal to the weight of 200 kg is applied to the opposite face. Find the shearing strain produced and the distance through which the strained side moves. Modulus of rigidity for rubber is 2 into 10 to the power 7 dyne per centimeter square. So the modulus of rigidity eta is equal to 2 into 10 to the power 7 dyne per centimeter square. Okay, and here the side of that cube is 7 cm and the force which is applied on that cube, that is the tangential force, is 200 kgf. So first we are going to convert that kgf into dyne, because here the modulus of rigidity and the length of that cube is in CBSE unit. So we are going to convert this kgf into dyne. So for that, 200 into 1000 into 980 dyne. Okay. And here we need the area of that cube. So area is equal to L square. That means 7 into 7, which is 49 centimeter square. And we know that the modulus of rigidity eta is equal to shearing stress divided by shearing strain. Which is equal to stress is F upon A and shearing strain is theta, right? So from here, first we are going to calculate theta, which is equal to F upon eta into A. Now F is known, which is 200 into 1000 into 980 divided by eta is 2 into 10 to the power 7 and area is 49. And after calculating this, we'll be getting 0.2 radian. Okay. Now this theta, which is the shearing strain, theta is equal to change in length upon L, which is the original length of that cube, right? So to find out the change in length delta L, it would be theta into L. Now theta is already known here. We have calculated theta 0.2 radian into length is 7 centimeter. So delta L would be 1.4 centimeter. Okay. So this is the answer, that the distance through which the strain side moves. So this is the distance. So change in length delta L is equal to 1.4 centimeter and the shearing strain is 0.2 radian. Question number 3. A metal cube of side 10 centimeter is subjected to a shearing stress of 10 to the power 4 Newton per meter square. Calculate the modulus of rigidity if the top of the cube is displaced by 0.05 centimeter with respect to its bottom. Okay, so the side of the metal cube is given, which is 10 centimeter. Then the shearing stress is given, which is 10 to the power 4 Newton per meter square. So first we have to convert this centimeter into meters. So 10 by 100 meter, which is 0.1 meter. Then the change in length, which is delta L, that is also given, that is 0.05 centimeter. And again we have to convert this into meter. So 0.05 divided by 100, which is equal to 0.0005 meter. Now first we have to calculate shearing strain. So we know shearing strain is equal to delta L upon L, which is equal to 0.0005 divided by 0.1. So eta, which is equal to shearing stress divided by shearing strain. Now we have everything. So just put the value of shearing stress and shearing strain. So 10 to the power 4 divided by 0.0005 divided by 0.1. And after calculating this, it would be 10 to the power 4 into 0.1 divided by 0.0005, which is equal to 2 into 10 to the power 6 Newton per meter square. So this is our answer. So the modulus of rigidity of the cube is 2 into 10 to the power 6 Newton per meter square. Question number 4. Two parallel and opposite forces, each 4000 Newton, are applied tangentially to the upper and lower faces of cubical metal block 25 cm on a side. Find the angle of shear and the displacement of the upper surface relative to the lower surface. The shear modulus of metal is 8 into 10 to the power Newton per meter square. Okay, so the force is given, tangential force, which is 4000 Newton. Okay, and the side of the metal block is 25 centimeter, which is 25 divided by 100, which is equal to 0.25 meters. Okay, so we have to calculate the angle of shear, theta, and theta is equal to, we know that theta is equal to force upon area, that means shearing stress, upon the modulus of rigidity, which is eta. Now here we already know about the force. We have to calculate area of that metal block first, and we know the shear modulus of metal as well. So eta is equal to 8 into 10 to the power 10, which is already given, Newton per meter square. So first we have to calculate A. So A means, area means L square. So area would be 0.25 square meter square. Now just put the value in this equation. So force is 4000 divided by area is 0.25 whole square into eta, which is 8 into 10 to the power 10. And after calculating this, it would be 8 into 10 to the power minus 7 radian. Okay. And here the displacement of the upper surface related to the lower surface that we have to calculate. So we know that theta is equal to delta L upon L, right? So delta L is equal to theta into L. Now theta is already here, 8 into 10 to the power minus 7 radian, and L is 0.25 meter. So after calculating this, we'll be getting 2 into 10 to the power minus 7 meter. So here is our answer. First, the angle of shear is 8 into 10 to the power 7 radian, and the displacement of the upper surface relative to the lower surface is 2 into 10 to the power 7 minus 7 meters. Okay.